All right, welcome back to Cloud on Air, everyone. My name is Kier. I'm the product manager on Google Cloud PubSub, a stream ingestion service. And with me today, as is the tradition now, is
Sergey Sokolenko. I'm a PM on Cloud Data Flow.
Now we're continuing our journey from big data to AI by talking about how you actually get the data into these beautiful systems that we've heard about. So BigQuery and ML Engine. We will talk about the pattern, which is stream analytics, and about the tools that make it easy on Google Cloud Platform. So you may have heard a talk that we've given a couple months back. This will be a different version. We'll have a new demo, and we'll try to give you a little bit more depth in terms of showing how the tools work. You can refer for more details to that talk as well.
And I think one of the interesting patterns, especially for AI, would be streaming predictions. If you would like to do predictions on your data, streaming is kind of a central component of this architecture. Don't you think?
Absolutely. And so it's worth clarifying that streaming it's very much about real time. It's from being able to take in data that used to take maybe hours and maybe days to ETL and take decisions on and make predictions. It's about taking it into maybe seconds and actually making predictions in real time, right, in seconds, and making decisions as you go along. But it's not just about that, and I think that's kind of the core part of the story, right? It's not just about real time. It's also about taking some of the sort of the classic ETL challenges that all of you, I'm sure, are familiar with, and simplifying them with stream analytics tools. So the way we'll do the talk is we'll do a little bit of an overview. We'll explain what we mean by stream analytics. Then we'll spend the majority of the time on Sergey's exciting sentiment analysis demo. I can't wait to share this with you. And then we'll show you how a customer of ours uses these tools in production in a critical kind of environment. So let's get to it. So as we mentioned, this is about real time. Right. Let's just be clear. Real time is what's seconds, right? This is what we're talking about. Data about events in the real world from when they happen to when you can do something about them using the machine learning tools, things like BigQuery and so forth. Examples abound. It doesn't really matter which industry you're in. Everything is kind of moving to real time. Certainly if you're in retail and advertising technology, absolutely critical there. In media as well, IoT has become a big use case. And in all of these cases, you have two types of problems. You have the classic ETL, right, where let's say in retail, you may have your inventory system, and you may want to take data out of that inventory system and sort of ETL it into a database that backs some kind of recommendation service, right? So you have a view of your inventory. But you also have this vast stream of small events that you might be using for things like fraud detection or recommendations, like clicks and taps. Which pages are people viewing? Which products are they seeing? So combining these kind of classic ETL things at large scale and doing them in real time and simply with this vast stream of data to be ingested to be into systems that can actually understand it and make predictions is the name of the game.
And the demo we're going to show will actually address one of these use cases where you have streaming, online interactions of your customers with your retail sites, and you do something with them to moderate the online comments.
Right.
All right, so among all these customers in various industries, the steps that we saw are particularly applicable to streaming analytics. Start with ingesting and delivering real-time updates. And many customers here are using your product, Cloud Data Flow, to do exactly that. Now, once data is ingested from a event stream and gets routed to a processing infrastructure, many of our customers are using Cloud Data Flow to do time-based aggregations. They calculate statistics. They do various kinds of counts and averages and stats based on time windows. In addition to using Cloud Data Flow for orchestration, there's also a set of tools that that are used for managing your jobs, your streaming pipelines. A couple of tools come into mind. Apache Airflow is a very useful tool to do orchestration of jobs. Now, so far we've been talking about how customers are moving the data and focusing on streaming to move data from sources to sinks. But batch processing still has a role in this process, especially if you have, for example, historical data that you would like to onboard and mix with your real-time data. Or another example would be you would like to reprocess all the information, all the events you've streamed into your sink and apply different business logic. That's another case where batch processing is important. And at the end of this data processing pipeline, we're seeing customers using data warehousing a lot. BigQuery is a big and important tool there. But we also see more and more customers are using AI systems and machine learning systems to do streaming predictions, so predictions on streaming data.
Right, and what's interesting is that a lot of the steps are not that different from traditional kind of ETL systems or streaming solutions you might already have in-house. The difference is in sort of the implementation and the tools that enable that. Let's make a very simple sort of try to simplify the story about what are these tools and what is really streaming and what's really different between what's going on and has been going on historically. Traditionally, the way we handle ETL of events and the ingestion of streams is we write them to files and then we move these files to a shared storage, and then we extract and transform the data. Similarly, with snapshots, you may just sort of you may not be using sort of files in a file system. But either way, the point is that you're moving around batches of events, right? The batches of things at a time, and you're managing probably on some kind of file system. What this means is that your code is written in terms of files, and your logic is limited to how big, the timing of your pipelines is limited to the delivery of these files, how long it takes to sort of fill one up, how long it takes to upload it, which is why kind of the typical ETL tool is often ETL pipeline.
Slow.
Exactly, right? You're typically waiting minutes, tens of minutes to an hour. Some people micro-batch, but that's sort of, it ends up being still batching, right, when you micro-batch. Now, with streaming, you're doing the same things, except there's no file, there's no batch. All the logic is written not in terms of what you do with a file, it's written in terms of what you do with a primitive sort of event in your application.
Individual data record.
Exactly. So let's say it's a record that says a purchase was made, a button was clicked, etc. Right? And so what this means, this has two effects. This means that your logic in the application code now is a little simpler because it doesn't have to think about files. Secondly, it also means that if need be, you can push your latency down quite a bit because you don't have to wait for the files to arrive. Of course, to make this possible, you need the right kind of tools. Cloud PubSub is an example of them, to ingest and make these events available efficiently without aggregating them into files. And similarly, you need a processing framework for these events that is able to take advantage of a streaming ingestion source like PubSub and perform the computation efficiently. So that's the overview. Let's see this in action.
All right, and for the demo, for the session, we decided to pick an example of a online comments sentiment analysis use case. Imagine you are an operator of an online retail site selling cosmetics and pharmaceutical products. You have a variety of great products. Customers come to your website. They do a quick review of what's available. They look, most probably they look at other customers' reviews. And based on these reviews, they make a purchase decision or not. One important quality of a data processing system that you build as an operator of such a site is being able to quickly distinguish is the user feedback positive or negative. With the positive feedback, that's relatively safe, but with the negative one, you either want to take it as an input into your product planning and inventory planning. Do you still want to offer this product if it got 10 negative reviews within an hour? And you also want to do some moderation, because some of the online comments might include unsafe language, some profanity. So you want to be able to moderate and filter. And this is an example that you see on a slide with the red online comment using some strong language and being quite negative about the product.
So an example of a very similar type of thing that you would have to do really quickly is in news sites, right? Where they're getting this content right away, and they have to react and rearrange how the content is presented very, very quickly, depending on what the user feedback is. You could do a similar thing with kind of a recommendation system in e-commerce.
And a colleague of ours, Eric Schmidt, he built a demo that shows in real time how a sentiment analysis piece of functionality allows you to reorder the products being offered to visitors of this online site. So let's look at the architecture of the system we built, or the service we built. The main flow of data is streaming. That's my main pipeline on the top of the slide. It ingests data from the retail side. Data gets routed through Cloud PubSub. This is my main ingestion point. I'm using Cloud Data Flow and the functionality of the business logic written in Cloud Data Flow to do the sentiment analysis. And then lastly, opinions, custom opinions that are already crunched and analyzed and annotated are being stored in BigQuery. So this is my main flow. Now, notice the secondary flow at the bottom of the slide. This is the case where I have historical data. So I have thousands and thousands of comments that my users or my customers have left on my retail site before I introduced this online system or online service. And so I want to take the files on Google Cloud Storage with the online comments and reprocess them using the same business logic I used for my streaming case.
Right, so you're never really starting from scratch. You're always sort of handling this real-time and backfill use case at the same time.
There is some history I would like to apply to the future. So with this, let me switch into demo mode and show you the streaming pipeline that I was talking about. You're looking at the Cloud Data Flow UI console that lists all the jobs I have processed and initiated over the past several weeks. One of the jobs is still running. This is my streaming pipeline that I launched just before my demo. It contains a couple of steps. Let me just explain what they mean. Each box in this diagram represents a data transformation. Something is happening to the data as it comes in and goes out. Each edge in this graph represents a flow of data, inputs and outputs from these transformations. And they're obviously connected. In the first step, since it's a streaming pipeline, I get my events, my records, my online opinions from PubSub. Then I do some light parsing and preparing and packaging this into a schema'd record, which I then run my sentiment analysis algorithms on. This is all done in Cloud Data Flow. And lastly, I'm writing into BigQuery. The only kind of complexity here is I'm actually using 3 BigQuery tables to store the entire user opinion or the user comment, and then individual chunks of this single opinion in just different tables.
So this index document step is kind of where all the application magic lives, right?
That's where the bulk of business logic lives. Yep. All right. So before the demo, I ran through a couple of events, and as you can see, the counters that represents how many records were processed at each step all say 2. So I ran two events just before we started showing you this. Let me actually go and emulate a new online comment being submitted through my pipeline.
Right. So in practice, this would be coming from your front-end servers that are serving the content and accepting post requests with the comments. But here we're going to do this just through the PubSub UI.
Yeah, I'm going to use PubSub UI, skipping the online submission step. I have a couple of online comments prepared. And let me take this negative one that you saw on slides. And I'm going to go to the PubSub UI, choose my topic, which is my input topic for the streaming pipeline. It's the documents one. And I'm going to insert, I'm going to publish a message on this topic, which contains exactly the text of my online comment that I want to analyze. This moisturizer, this product is useless. It smells horribly. I'm returning it tomorrow.
Not a happy user.
Not a happy user. Perhaps you want to moderate, as an operator of the site, moderate and kind of get the signals before you release it to your website. So now this message is out, and let's switch back to my streaming pipeline and kind of observe what happens to the steps and the counters as data gets.
This is where we're looking.
Exactly. So the counters have changed to 3. I used to have just 2 elements. Now it's the third element is moving through my pipeline. And if you go through each step, you see the counters have changed to indicate that we did process an additional online comment, and we did write it into BigQuery. And just to complete the flow, I wrote a couple of query statements that would show me what exactly is in my tables in BigQuery. That's the statement. Let's run it. It shows all the records ordered by time, but in reverse order. And so the latest record will actually be shown first, and that's my new record that was just inserted. It's UTC time, but you will recognize the text of my comment. And what's cool actually here is I have some interesting annotations for this text, which show me the places in the online comment which indicate disappointment of the customer with the product. Totally useless is the language being used, or horrible smell. The N that stands before the text represents negative opinions. And I also know what it is about, the entity of this opinion. It's the moisturizer.
Right. So in this case, the data analysis team or product analysts within your company can then go and sort of understand what's happening with the different products and sort of understand the overall sentiment. But you could also have sent these events to something that's a little, that actually responds to the user's demand, right? Be it sort of a cloud function or an app engine.
Yeah, we've got some numerical data, scores of sentiment, and various scores for each of the dimensions. So for example, we have a negative score here and some other scores too. Let me quickly show you the example where we actually run the same code that runs my streaming pipeline, but in batch mode. I'm going to switch to Eclipse. This is my preferred development environment. And Eclipse now shows you the code of my pipeline. It's in Java. There are a couple of steps here, but I'm going to go ahead and launch this pipeline and start executing. The differences between my execution configurations for streaming and batch are really just in the parameters I use for the pipeline. For example, the parameters I use for streaming tell me streaming equals true, and my sources pops up. For batch mode, I use slightly different parameters. Streaming equals false, and my source is a file on the GCS, Google Cloud Storage.
So this is what we're going to launch, the batch version of this.
Exactly. I'm going to press run. I'm going to start executing, and within a second, I'm going to see a confirmation that the job was submitted. So with this, what we've seen in the demo, we are an integration of a sentiment analysis package with Cloud Data Flow. We have the main data processing pipeline that runs in a streaming mode. And we still have access to a batch capability that runs the same business logic just by a change of a few parameters.
Well, not only that, it's actually running the same code. You have it pulled up here, and it seems like the only difference between the batch case and the streaming case is sort of the definition of where the data comes from.
Exactly. If my parameter is setting streaming to true, if it's a streaming pipeline, I'm going to get my raw inputs from a pub subtopic. If my streaming parameter is false, I'm going to get my input data from a GCS file.
And so in either case, the step sort of emits the same data structure. Recall it, in this particular case, it's a peak collection of strings. And so then the rest of the code that you've just seen is sort of, that's the code behind the visualization that we saw in the data flow UI.
Exactly.
So now you have these, you've sort of seen a pipeline in action. We'll tell you about an actual production use case. That was a demo, not three events, not quite big data. But this customer of ours, who've been gracious enough to sort of write up their experience in a blog post on the Cloud Big Data blog recently, called Traveloka, do this at real scale in a really critical application. So Traveloka is a travel technology company. They produce mobile apps for booking hotels and flights and sort of other transportation related things. They're based in Indonesia and have been very successful over the last couple of years. So a company has gone through rapid growth. And what's interesting about this particular application, so travel technology, among other things, is that having a very robust real-time data pipeline is actually central to the business. In order to stay competitive, it's not just about sort of being able to connect your reservation system to your payment system and just basic plumbing. You actually have to do intelligent things. And so, so you have to build a data analytics stack that supports use cases like real-time personalization, fraud detection, which has to be fast. You have to optimize, you have to do A/B testing. So there's a lot on the shoulders of the data science.
And I bet perhaps in some scenarios the opinion sentiment analysis might actually be actually quite useful for them as well.
Oh, I am certain that they're getting reviews. And so what the team there has done is they built a system like this, which is actually a very common pattern on using virtual machines on a public cloud provider. The input is our events from Android and iOS apps like taps and clicks and search strings, and the output are services that the app provides itself. So let's say these would be recommendation services, testing services, fraud detection, as well as BI analytics UIs. So in the middle, you have two pipelines. There's a streaming pipeline. They're using an Apache Kafka cluster to populate the operational database in real time. They're using a document DB. They also have two data warehouses. One of them is a memory relational database, which is serving kind of fast historical queries in business analytics. And you have a batch pipeline, which is now operating at the scale of tens of minutes, which has a couple interesting components in it. So it's taking data persisted by Apache Kafka. It's using Goblin to dump this to a data lake. And now from there, they've created two separate warehouses. One of them is to support the data engineering loads, right? So existing dashboards and sort of pre-canned algorithms that require more data than you can store in an in-memory database. And you also want to give the data science team an easy kind of SQL interface to the entirety of history without affecting the production data. What's interesting about this is that this was a successful solution, but the issue is that each one of these boxes is a cluster of machines that's running software that the team is managing. And so as they've met their success, people started getting paged at night and on weekends, and eventually somebody got paged on their honeymoon. So they decided it was time to rebuild, and the goals were fairly simple. Migrate to a fully managed stack, so people didn't really have to answer as many pages. They also wanted to make sure that the overall pipeline latency, right, from the app back to the app or back to the BI tools was low. It was consistently low with a high availability system, and everything just scaled because the company is still growing. And so with that goal, this is what the team ended up building. The inputs and the outputs stay exactly the same. What's happening now is that they've used Cloud Pub Sub for ingestion. Cloud Data Flow is now doing processing of the events, and now there's a single data warehouse for both the data science teams and the data engineering use cases. That's BigQuery. You've heard quite a bit of that. And what's interesting is that they've made a choice to put the operational database on a separate cloud provider. They had their reasons for doing this, but I think what's fascinating about this for me is that it just sort of illustrates the point that going fully managed doesn't mean kind of getting yourself locked in. You can pick and choose the tools that you want. As you've seen before, they are doing this exact thing where they're onboarding historical data from cloud storage while streaming real-time data. So I think the real success here is that it took two engineers just a month to build the system from a proof of concept to a full-scale pilot that I believe is in production now. They did achieve their end-to-end pipeline latency that's in seconds, right? There's no longer that batch arm, right? Everything is operating at the same time scale. They did achieve their goal of scaling without with a no-ops kind of pattern. Somebody else is taking care of the scaling for them at hundreds of gigabytes a day of data successfully ingested, and most importantly, made useful through various BI tools. In particular, they were able to migrate literally thousands of dashboards and hundreds of users of their BI tools within that month. So this kind of concludes the main part of this session. Just to briefly review, we've sort of talked about stream analytics as a pattern to both simplify ETL and also enable real-time applications. We've showed you an example of how this works. It was a small example where we did a very deep kind of computation using natural language understanding, and then we gave you an example of a customer of ours who does this at a much larger scale and a much more demanding application. You will find details on many of these things in our blog as well as in other webinars. But to wrap this up, the lesson is that with the right sort of tools, streaming can be headache-free, right? It can be easy to adopt and can be fully managed for you, so your costs actually get lower, both in terms of complexity and in terms of actual management. You're not only getting real-time results, you're also sort of simplifying ETL problems. And with data flow, you don't really have to give up batch to switch to streaming. So with that, we'd like to encourage you to keep posting your questions. We'll be answering them live. Sergey, I see you've posted your demo online.
Yep, if you would like to try out the demo code, navigate to GitHub and check it out.
Happy streaming, everyone.
If, for example, there were two sessions running at the same time, then you can watch the second session later. Welcome back to the big data, people. Just to recap there what I was saying, all of these videos will be available later on. So if there's something you didn't catch, you had to step away, there was something you wanted to watch in parallel, that's all available to you later. Also, as a reminder, if you've got questions, as people have been doing, if you have questions, please just ask them live. You can do that from the link on the top left of your screen. So you can ask a question live. We've got people here answering those questions right back in the moment for you. I'll bring some of those questions along to the next time that we're together. Also to say, if you do want to have a look at the agenda and see which sessions are running in which tracks right now, then that also is on one of those icons up on the top left there, so you can see which sessions are running. If you want to stay in the same track, just do nothing. It will automatically go back to the industry solutions or the big data or the AI, whichever one that you were in. If you do want to switch, then just look over to your right and you'll see that you're able to switch between streams. And like I say, all of these will be available later on. So don't stress it if there's two that you do want to watch that are pretty much the same. And just as a recap, of course, this is this global on-air event. Thank you ever so much for joining us. We really, really hope it's useful to you. In fact, I've been watching these sessions. I'm surprised how much I'm picking up, even though I live and breathe this stuff every day. So if I do, I very much hope that you do too. In any case, we're going to switch now to the next sessions, and I will see you back here very shortly. Thank you.